Good morning, good afternoon, good evening, whatever time zone it is from where you're tuning in today. My name is Blake Croney. This is the Wi-Fi 6 webinar. It's a part one of another three-part series. This is the deploy. We're going to be talking about building a backend to support Wi-Fi 6 and 6E. I've also got Julio here as well. Julio, want to say hello and give a quick little intro?
I sure can, Blake. So, hey, everyone. Thank you for joining us. Julio Petrovich here, product manager at NetAlly. Hey, just to help answering questions and stuff on the background. So, if you have any questions, feel free to type them on the chat.
Yes, thank you, Julio. It's a pleasure to have you here and be talking with us on this today. So, as Julio mentioned, that please use the chat. All the lines are muted so that we don't have to worry about anybody off muting and getting audio going crazy and everything. So, answer or ask any questions in the chat. We've got plenty of time at the end for questions, but also if there's something as we go through the slides, if it's something that you want to ask, please do ask it. Julio will get my attention if it's something that we want to stop right then and there and talk about a little bit in depth while we're on that particular slide. Otherwise, we will either answer it in the text chat or we will answer it at the end of the webinar today. This webinar is being recorded, so you will receive the on-demand version as well as a PDF of the slides afterwards. If any of your colleagues, coworkers are not able to attend today, if you found this interesting and something that they would want to look at as well and watch, we do have the link in the chat right now, and it's also going to be up here on the we'll be talking about here in just a little bit as well on the next slide, where we'll be able to get through it. So what do we want to talk about today? So we already did our quick intros. The main things that we're going to talk about here, again, because this is the back-end services, not necessarily talking about Wi-Fi 6 and 6E and the fundamentals of wireless, but what we want to look at is some of the things that are sometimes forgotten about when we go through and we do projects. And primarily, I wanted to look at two main topics here: the authentication, implying the who, what, and where, because we can't really just look at it as who anymore. We have to look at all of this. So we're going to talk about a little bit about identity management. And one big issue that I constantly see with wireless projects, and I think we're going to see this more and more as we start getting through with the Wi-Fi 6 and Wi-Fi 6E as more devices come on this, is how do we support failovers? This is a big issue out there, is we always worry about trying to make it perfect. And I can tell you, things aren't always perfect. Things go wrong. I mean, I can tell you there's been numbers of times that I've accidentally pulled a power cord when I've been working on something, or accidentally did a right config and all of a sudden it reboots on us. Many of things go wrong on there. So how do we handle those failures or those failovers? And what do we need to take in consideration about that when we're designing our backend services? And then we'll look at the IP services or the plumbing of being able to get us online and actually get us working. Talk a little bit about VLANs and segmentation and how do we segment the networks properly for all this influx of devices that we're going to have. Wi-Fi 6 and Wi-Fi 6E is going to be big for IoT devices. It's not necessarily getting that iPad or getting that iPhone connected and be able to have blazing fast speeds. It's also about how can we scale to thousands of IoT devices and be able to support those safely and securely through DHCP scaling and DNS queries, looking at all of that. So that's kind of, real quick what we're going to talk about throughout this one. And as I stated, this is part one of part three. So there's going to be more parts coming on here afterwards as well that we're going to be looking at over the next couple of months here. And some of the animations we have to multi-click through on this with BrightTalk, but let's get through it here. So here is that link that I alluded to. It is netally.com/Wi-Fi 6-6E-series. That's where we have a whole plethora of information about Wi-Fi 6 and 6E. We've got blog posts. We've got previous webinars from Mike and James went through and talked about some of the basics and fundamentals of what it means to be Wi-Fi 6 and 6E compatible. Talked about some of our tool sets that we have out there now that we have the support for that 6 gigahertz network in the newly released and newly announced AirCheck G3, the NXG300. We've got plenty of devices that we can do this. So today, we start off my 3-part webinar series with the part one, deploying a backend to be able to support this. On January 10th, so next year, what we're going to look at is how do you get people on fast and frictionless? That's the thing about Wi-Fi is I go to restaurants with my kids and it's always, where's Wi-Fi? We sit in the car, it's like, where's the Wi-Fi? They want all these devices connected. They don't necessarily have a cellular-based iPad, or my youngest, he doesn't have an iPhone yet, so he's still trying to get connected. And it's funny, as I listen to my son and my daughter talk in the back seat about getting his iPad connected to her hotspot on her phone so that they can play Roblox together. So it's all about how do we get this devices on as quickly as we possibly can without a lot of issues for that end user, because that's what we ultimately want. So that's part 2. Part 3 is where we're actually going to put a lot of this into action, and we're going to be talking about, speaking of that AirCheck G3 out there, you're going to be able to win a date with a handheld, aka we're giving away an AirCheck G3. So I'm really excited about this. Brand new device out there, huge upgrade over the G2. It's similar, but it's better in a lot of different ways as well. We're bringing a lot of the NXG feature sets down into that G3 platform. So we're going to look at how can we do a lot of what we just talked about through part 1 and part 2. How can you actually use that tool to be able to look at some of these data points and understand what's going on with your network? So one of you is going to be able to win that, and winners will need to be present for the drawing that we will be having on February 14th. So it is Valentine's Day, hence the pun on winning a date with a handheld there. We thought we'd be a little bit clever. I don't know, I'm not marketing, but we thought we'd try this and see what would happen on it. So we're going to be able to give away that. We'll have more details on how you enter into that as we get through that. There are some terms of that, obviously. If you're a NetAlly employee, you can't enter. If you're a distributor, can't enter. If you're part of the academy, the NetAlly Academy, you can't enter. There's some disclaimers about that, but we'll have all those details out there. I know, Julio, sorry. If you left yours in Antarctica from your last trip down there with the penguins, you're not going to be able to win a replacement one. Speaking of which, I think I was supposed to be sending yours to me, I thought was the deal here. No. So that's the schedule that we got going on over the next couple of months here to wrap up some more details around this Wi-Fi 6 6E series. Again, please bookmark and please head to that link. There's lots of information there. We've got all the recordings there. A lot of good content up there to be able to help you on your journey for supporting Wi-Fi 6 and Wi-Fi 6E. So let's go ahead and let's dive into this and let's get started on it. All right, so this is something that I say quite often when I'm talking with my customers and we're looking at the different deployments out there. You're only as solid as what you build on, and foundation is so important. I grew up building houses, doing remodeling. Yes, my wife, our house has been under remodel since the day we built it. So hopefully eventually here, 15 years later, I'll get done with this eventually on there. But a lot of what I've had to do on this place has been because there's been things that, corners have been cut. There's been shortcuts taken as people have remodeled. Not everybody has the same skill sets as others do, and they don't necessarily understand how to do all the work on this. And this is true in any network design out there. It doesn't matter whether you're a wireless engineer, a cable installer, a server administrator. It doesn't matter who you are. The foundation is always key to this. And if we don't build a solid foundation, we keep compounding that into what we always refer to as the technical debt. That whole issue of having something that we're trying to support that we can't easily support because somebody did that 5 years ago. Well, that'd be like in the ancient lifetime in tech. More like somebody did that 6 months ago, and now we're trying to support it. That person is no longer with the company. They don't, we didn't document it. Tons of different things can go on to this. So what we want to look at here through this discussion today, again, is that back-end services of what's important for you to look at from bringing up connectivity. And these are some things that I see on my customer sites when I go out and I do deployments, where we start to get some of this stuff put together, but we focus so much on wireless, or maybe we focus too much on cable, and we focus on the wrong areas of it. So what I want to do real quick here is I want to open up a poll, and I want to ask this question real quick here. So let me see if I can do this here. Let's go over here, start poll. So we'll give you just a couple of minutes, about a minute or so here to answer this question. Is, during your day-to-day tasks, which areas are you involved in? Do you do cabling, IP services, wireless, server support? Are you that jack of all trades that is the go-to person for your company? Everything gets answered, or everything gets asked for you. You have to look at everything. there's not another person that you can support on. Or are you just a cable instructional engineer? And I don't say cabling as just a cable instructional engineer, because there's so much importance to that back-end cable technology that we need to have a strong cable plant, obviously, in order for our backend to work. And we're not necessarily looking at that cable plant here today, because we've talked about in the past about you need to have Cat 6, Cat 7 cable. You can't be running on Cat 3 cable because we don't have that PoE support out there. Or are you just a server administrator that's looking at it from IP services, DHCP, DNS, VLANs, the wireless side of things? Maybe you just do server support of Windows servers. Bless your heart, I did that for many years, and man, that patch Tuesday and then having a change window on Sunday nights to try to do 300 surveys. Oh, I'm so glad I'm not worrying about that anymore in there. So we look at this, and a lot of times what we end up with is we end up where folks are kind of in silos at times. And I'm going to go ahead and just give this just a couple more minutes, because I still had some votes coming in here that I can see clicking into this. All right, so let's wrap that up and let's see here. So we've got about 50% that are doing IP services. So you're doing your wired and your wireless side of things. We've got some structural cabling only folks, and then we've got cabling and IP services, everybody at 33%. And this is kind of common where I see is that we don't necessarily see people doing all of it. We start to see where we get into what I refer to as these tech silos. And the tech silo problem that we have out there is that we get asked to focus on one area. So you're starting your new career, you're either fresh out of VOTech, fresh out of college, or maybe you want to start a new career. You're going to go down a new life path. You already did something else. And you're like, hey, this technology thing, I guess it's not a fad. The internet actually is going to stick around. I might want to get behind this and do some work on this. So we generally see where folks get and they start picking different areas of this. And this cabling and the power side of things, I see a lot of this being as the folks that were electricians, they started diving into this because, well, we run cables already for mains, your 120 or 204 volts, whatever it might be in the country that you're living in. So now we're going to start to run this low voltage cable as well, because in the past they were running all the phones, they were running all the RG6 for cable TV coaxial connections, whatever you're running off of that one. Or maybe you're part of that group that is doing audio video setups. So for the conference rooms, you're running all the HDMI cables in the walls. You're trying to get all of that patched together, but you also need connectivity for those devices. So we end up with this first silo of it's cabling and it's the power. And it's for that side of things, it's all about is, again, what's the right cable standard to use? Do I use Cat 5e? Do I use Cat 6? Do I go all the way up to Cat 7? We try to look at this as what do we actually need from a bare minimum? And Mike and James did some good discussions on this in the previous webinars on some of the differences between the cable standards and what you should work at. For us, from a Wi-Fi 6, 6E perspective, as long as you're running Cat 5e or greater, you're going to be fine for what we're looking at, because it's going to support the right PoE version. That's a big thing for us in our deployments, is making sure that we have appropriate PoE. And I don't just mean support of, yes, you can do AT PoE or you can do high power PoE. It also comes down to is, do you have enough budget for that? And that's something that we're going to talk about when we look at physical segmentation of the network. What are some of the pros and cons of that? And what do we have to be careful about from a PoE perspective? Because it always comes down for me is that budget aspect of it. The next silo that I see is this IP services, the route switch folks. Prior to wireless, this was the cream of the crop. This was how you got connected. Everything was about how do I configure that switch? How do I make sure that you've got your IP addresses allocated properly, making sure that you're following the appropriate class A, B, C, RFC space IP addresses, making sure you're using the right addresses in the right way. And this was how we did our network segmentation. How did we isolate Julio and his bad actor laptop, because he's been traveling the world lately, so we're not quite sure what network he's plugged into. So maybe we want to plug him into this safe network over here and make sure that he's got his virus definitions updated and ran a malware scan, things like that. Getting that switching, that routing working, and then the name services as well. The name services is a big one for me, is because people always seem to forget that name services. We're going to talk more about that though here in just a little bit as we look at these silos more in depth. Now, NetAlly, a lot of folks understand NetAlly from either the cable tools or the Wi-Fi tools. Because if you didn't know, the history of NetAlly came from Air Magnet, Fluke, NetScout. I'm not going to pull out the card and do the little speech. We don't have to go to that level anymore. But we had a lot of wireless tools that we work with, and that's how a lot of people understand NetAlly. So wireless is a big silo, and it always is a silo because I know plenty of engineers out there that they're like, I look at wireless and I put my blinders on, and that's the only thing I ever talk about. I don't do route switch. I don't do cabling. I don't do server admin. Yeah, I need this. I need this DNA center, or I need this ClearPass. It's installed on VMware. Here's the data sheet. Go install it for me. And that silo is dangerous to be in from the wireless perspective because yes, wireless is tough, but everything else we have to make sure is working in order for our wireless to work. And then finally, there's the application layer. And this is the layer that the users only know about. Users care about, can I get on Facebook, Instagram, TikTok, Be Real, whatever the flavor of the week is for kids. It's like, seems to be that my teenage daughter is coming down almost every other day with a new app like, hey, can I get screen time for this? And it's like, what is this? Let me look at the privacy. Okay, what do they collect on you and all this? And we have to go through all this. But at the end of the day, they just care. I want to connect to this app. I don't really care where it's hosted. I don't care which country created it and what they're tracking on me. I just want to use the thing because all my friends are using it. And that layer, that application or that application silo on it, if it doesn't work, the internet doesn't work. That's the thing about it is, if we look at this and say, I can't get connected to TikTok, I can't get my little 3-second blip of whatever else and my swipe, trying to watch all these videos, the internet is down. The connectivity is down. That's the assumption that people make. So these are the 4 silos that we have out there. And today we're going to talk in depth about this IP services one and authentication to be able to go through all of this, building up into our wireless in there. So IP services issues. I call it the sometimes forgotten layer. I say it's forgotten because a lot of us just assume it works. How long have we gone through and plugged in a network cable into a jack and got an IP, got connected, completely blind and oblivious to how it actually works and that we get routed onto the network? Pretty much always. We take this for granted at this point in time. I will say is that we are almost at the point of taking wireless for granted as well. But wired has been taken for granted quite a lot because of the fact that we have decades and decades of experience on making a wired connectivity work in some shape or form. But it's extremely important that we need to look at how all the different layers of IP services can impact that. Auth services, the radius server, ICE implementation, ClearPath implementation. That's a big one. Segmenting, how do we keep each other safe when we ultimately get onto that network? How do we make sure that those IoT devices that probably have a common backdoor username and password are not on the same network as my finance systems? Because I don't want those to be the entrance point for my network to be compromised. Ransomware is a huge issue right now. How do we keep ourselves safe through segmenting everything up in there? It's not just IP addressing, though. This is what we used to consider as the best way of doing this segmentation and security was through IP addressing, because then at the firewall, what do? I restrict access based off of the IP address that they're coming from or that IP address range. That presents some hurdles and some challenges that we're going to look at here with Wi-Fi 6 and Wi-Fi 6E in terms of how many devices we have out there. So we look at that IP address as it's no longer a valid means of security and segmentation. We have to change our thought process on that. And then a big one in wireless is name services. And we'll talk about why I consider this one of the big ones, because it has such a huge impact as to whether or not your device thinks you have connectivity. All right. Engagement. You guys didn't know that you're going to be this engaged on this webinar, did you? Don't worry, we don't got a ton of polls, but I want to ask this question as well here. So let me activate this poll. Okay. Which type of authentication system do you use? And this could be across the board, wired or wireless. It doesn't just necessarily mean your wireless authentication, but across the board, what are you using? Are you using a plain Radius server, such as like Windows NPS, or heaven forbid, at least you're hopefully off of Windows IAS and you're not still using that? Or are you using an identity management system like ClearPass or ICE or SecureW2? Any of those that takes into consideration more than just a username password, but also what type of device, where you're connecting from, things like that. Are you just leveraging pre-shared key? Don't get me wrong, nothing wrong with pre-shared key, okay? I have a lot of folks that always come up to me and they say, well, I'm using pre-shared key, I want to move to Radius because it's more secure. Well, let me be honest with you for a second there. If you have a very strong pre-shared key that's random alphanumeric symbols, heck, even emojis now you can put in a lot of them, it doesn't matter. If you have pre-shared key networks, there's sometimes that pre-shared key network is more secure than the Radius or the identity management network that I'm there to support and talk with, because I can get a username and password so easily, or I can export certificates, things like that. So not here to bash about pre-shared key. This is more just a question of that. Or are you using no security whatsoever? You're out in the boonies and all you have to worry about, like, I don't know, Julio down in Antarctica, do they actually use security down there? It's just this big vast ice sheet. So if you didn't know, Julio just got back from the trip, and one of the spots that he took, check out the NetAlly Twitter feed, because he's got a picture of him with the handheld devices down in Antarctica, and I'm extremely jealous of that, because I would love to be able to go down there at some point in time just to experience that. All right, so we're going to end this. So, wow, overwhelmingly large number of you are using identity management. That makes me happy, because that's what we're going to be talking about here, as to why the importance of being able to use identity management over just a Radius authentication. Now, all you that said you're using identity management, you're also using Radius most likely, because you had to deploy Windows NPS to attach to your Active Directory domain to be able to communicate with ClearPass, but we're augmenting that and we're building on top of that by leveraging this. So, auth services. The authentication services they're simple at times, but they're really highly complex when you actually try to deploy it. And there's a reason behind this, because there's a lot that's going on about it. We have to first establish our encryption protocols. How can Julio and I exchange our communications securely? You might equate this to using something like Signal, for example. You want to be able to have a secure, direct communications method between two parties. So you could use something like Signal that has end-to-end encryption for your text messages. In order for that to work, the first thing that has to happen is we have to be able to agree upon a set of encryption protocols. And when we're agreeing on those set of that encryption protocols, that's a process. It takes time. We have to accommodate that inside of our timing for getting our client devices online. If I take too long for that encryption protocol setup, or that negotiation process, because there's a couple dozen different ways of doing this through the EAT methods, the extensible authentication protocol methods. If I have it where my server is configured to say, yes, you can do EAT keep V0, V1 with MS Chat V2, with PAP, with all these other acronym alphabet soup going on in there, I have to look through each of those to say, can me as a client device, can I support that? Yeah, I see the server supports that, but what do I support all that with? What do I want to be able to negotiate with? And the longer that process takes, that adds delay to the authentication process. And one of the things that we're going to look at on Valentine's Day, when you have the opportunity again to win that AirCheck G3, we'll look at how we can look at this with the auto test profiles and with the Radius testing profiles, to be able to look at and say, how long did it take for this process to happen? How long did my client device have to wait to be able to send up that request, that identity? So once we get our encryption protocol set up, whatever it might be, then we actually have to send our identity. And there's multiple different ways of sending our identity, either protected or unprotected. And obviously with unprotected, it's the same as, you go to get your mail and the address is unprotected. It says Julio lives here. This is what his address is. I send him a package that I have to know that. Well, anybody that is processing that mail obviously sees Julio's name and sees what address he lives at. So if they're looking at that and they say, oh, I want to go TP Julio's house because he didn't give me a good enough deal on my last purchase. All right, so here we go. We're going to see that and we say, oh, Julio lives here. It's unencrypted. I can just by glance see that, and now I understand at least part of that information. Same thing happens with identity processes, where I could send my username. Well, if I send my username up and I'm using passwords, now I have 50% of that login information already determined. I just need to brute force that password. And hopefully we follow all of our password rules so that Julio's password is not just password 1 or password 2, whichever number increment he's on for this go around. So we can't brute force that quick enough to go through it. So sometimes we want to protect that identity. And by protecting that identity, leveraging something like a EAP tunnel with TLS on the tunnel for the inside tunnel, now I can ensure that, well, they'd have to strip the SSL encryption. They'd have to strip and break some kind of encryption even to begin with to get that username. And what I send in the outside identity is I just send a random fake username. So they can go ahead and try to use that username all day long, but it's never going to get access to anything. It's never going to be able to get through anything because of the fact that it's not a legitimate user. It's just some blind information in there. Finally, now we authenticate the identity. We finally say, yes, this person is correct. They've gone through this process of negotiating it. So it says, we want to do eat peep. We want to do a username password. I've requested that username and password. That username and password has been received. Now I can finally say, yeah, who actually are you? Are you this person? And should I authenticate you? And should I authenticate you just based solely off of that username and password? What's the problem with just basing it off of a username and password? Well, the problem that we run into when we base it just off that username and password is what device was that actually on? Do I trust that device in any shape or form? Okay. So that's why we have to ask this next question whenever we're doing our authentication, especially with Wi-Fi 6 and 6E as we get all these IoT devices. Is it's more about who, what, and where. Again, I said the who is easy. We're looking at it from a pre-shared key. So if it's a pre-shared key, basically the identity is the same for everybody. It's whoever's got that pre-shared key. Okay, yeah, that's the identity. If it's a username and password, I hope that you've protected your username and password well enough that you're not just giving it out. And that's one of the things that I'm slightly a little bit scared at as I watch again my kids and how some of their friends work. Not my kids. I've been trying to train them well enough on this, but it's so like they want somebody to be able to log in because they couldn't log into Roblox, for example, so they couldn't get that daily reward. So like, hey, here's my username and password. Can you log in for me real quick? And can you retrieve this for me? And it's just like, no, you don't share passwords like that. We don't want to share that username and password because once that username and password is out there somewhere, if it's something like an Active Directory account, now I can use that on any device and I can at least check that as to see if it's an easy way of getting in somebody's network. Because I can almost guarantee you, majority of people that use WPA2 Enterprise or WPA3 Enterprise authentication are leveraging username and passwords. I still see a very few number of my customers that are using certificates or trying to migrate to certificates. One of the reasons being IoT devices. We got a lot of IoT devices out there that it's really hard to get a certificate deployed onto. So if it's really hard to get that certificate deployed onto that makes that's a higher friction, harder to get the device on, which we'll talk about in the next webinar. That's going to cause problems onto it. So the who is easy. We've got that right now. What we want to do is we want to start building on that. The what. Now we can look at what if we use something like an identity management platform like ClearPass or ICE or some of the other ones out there, because what I can do is I can start to profile that device. And by profiling that device, huge fan of Criminal Minds. So, you look at profiling, it's about building a signature about what a device looks like or how a person acts or, their persona. So we're trying to build this persona of a device. And we look at it and we say, okay, I have a device here. I have my iPhone. If I put my username and password on that iPhone, how do I know that I should trust this device entirely and give it access to, if I'm in finance, how should I know that I can give this access to this device of the finance servers? Now I could go a couple steps further where I could look at it and say, okay, the OUI, the MAC identifier of this is an iPhone. So I understand that it's an iPhone. But now I want to go next step level, as I want to say, okay, is that device a part of my mobile device management platform? If it's part of my mobile device management platform, okay, I can see and say this is an actual corporate issued asset, as opposed to it just being, well, somebody bought an iPhone off of Best Buy or eBay, Apple Store, wherever, and they put their username and password on it. So I'm not going to trust it as much. I'm going to look at this and I'm going to say, yeah, okay, you used your username and you used your password, but I don't quite know what device it is. So kudos to you. We're going to encrypt your traffic. We're going to do that. But we're not going to give you access to key systems. Okay? And the thing that you have to be careful about profiling is that it's not 100% precise, because I can spoof MAC addresses. I can spoof user agents. You know that a user agent is another thing that a lot of these profile engines look at, because of the fact that when this device connects, it tries to do what's called the captive portal network authentication test on it, and it's looking to see, is there a captive portal on the network? If there is, well, that's a query. That's a web query. We can try to intercept that web query, and we can try to get the user agent out of it. I can spoof all of that. So there's a lot of things that we can spoof that we have to be careful about. Again, we're trying to layer this. We're trying to put all these things together instead of just looking at one or the other. Or what our last one is, the where. The where is becoming extremely important. We all understood and went through the past couple of years of COVID and how that changed how we access the network, how we access our systems, how we did businesses. And for a lot of folks, I think one of the things that we realized as organizations is that there's very little that we're accessing in our facilities these days. Most everything is up in a public cloud. So I can be working from anywhere. A good friend, Jonathan Finney, he's a wireless engineer. He travels the world and he's working from all over different places. And it's one of the things that he's become a pro at, is that, as long as he's got connectivity, he can do his predictive designs. He can do his survey reports. He can do XYZ job functions as long as he has connectivity, because everything is off of public cloud infrastructures. So now it's really important to understand the where. Where did you ingress into the network? What was that AP? Yeah, what was the actual network IP range that you're on? But physical locations too. Are you in one of our offices? Are you in a home office? Are you in a coffee shop? Are you at McMurdo base down in Antarctica? How should we treat you differently based off of where you're connecting from? Understanding the risks of who's around or who could be around. You don't think about it too much, but my wife's in HR, and with her being working from home now, there's a lot of conversations that she has to have with her employees that are privy that I shouldn't even necessarily hear about, because it's not, it's none of my business. Pay scales, things like that. If there's improvement plans, whatever it might be, we're only one floor separated between each other. That's a big difference for when you're looking at how do we even consider people from what they should have access to. Because if their computer's not locked, we joked about nobody locks their computers in the office. I bet you nobody locked their computers at home. So the where now becomes extremely important that we have to look at as well. And we have to put all of this together. And you probably heard this concept out there. It's, buzzword bingo. So if you're still playing tech buzzword bingo, here you go. ZTNA, or Zero Trust Network Access. And this is going to become extremely more relevant with Wi-Fi 6 and 6E, because of how flexible it gives us connectivity options for IoT devices, for our laptops, for our tablets, our phones, our watches, everything that we have out there on this. And these four core concepts are extremely important to us as we secure the networks and secure the backend going forward with Wi-Fi 6 and 6E. The first one is that we need to assume a least privilege access. Gone are the days where we just completely block access. I can't remember the last time that I've completely blocked access to somebody. What I'm doing now is I'm giving the minimum level of access permission that they need just to simply get connected and have connectivity to the internet, to be able to do a browser session, for example. Because at the end of the day, we want people to be able to remediate themselves. We want them to be able to at least get connected enough to be able to open up a help desk ticket, or be able to get through to somebody to say, hey, I have problems. Why can't I access this information? So we give them that least privileged access, and we verify who they are, then trust that they have the right access. So we look at this by our authentication systems by saying, okay, yeah, you put in that username, password, yeah, you have that certificate, but do I still even trust you of what you're supposed to be doing is correct? Should you actually be able to access that infrastructure? Maybe you shouldn't from that device. Maybe I should only allow that from key devices, because maybe there's a hardware license associated to it or something like that from a licensing standpoint. So verify, then trust. And the important part about this is we have to continuously monitor this. I know a lot of folks out there that we authenticate and we let them on, and that's it. We don't ever re-look into it and say, was there a change of authorization that happened? And wireless, we actually did this quite often because we needed to, it built into us to be able to re-up our encryption keys. We have these session timeouts. We have all these options that we can configure inside of our controllers or our dashboards, whatever you're leveraging. So it's something that we've been doing, but we haven't really been doing it to the full extent of saying, okay, we keep your encryption keys fresh so that if anybody were able to compromise those encryption keys, maybe an hour later, 4 hours later, whatever your timer's set at, they no longer are valid, so they can't do anything with it. So we looked at all of this as we have to continuously monitor everything. We have to be able to look at it and say, yes, you're still good to use this. No, you're no longer good to use this. We all saw this play out in a very infamously large scale on a recent Twitter takeover with Elon Musk. All the workforce was in flux for those first couple of days. And the first thing they did was, we're going to block access to everything. We're going to lock down the office lock down access to the office, lock down network access, all of that, which is extremely important to be able to have that ability to be able to revoke those keys quickly, because we have to understand where we're at this moment, not where we were 30 minutes ago. Where are we at right at this moment to ensure that that access is still valid and that device should still have that access. So it's a continual cycle that we have to go through there. And finally, always assume a breach. We must always assume that a breach has happened or will happen, okay? Because at some point in time, you're going to see a bad actor on your network, and we have to determine where it was from to understand how we can alleviate or how we can remediate and fix that loophole, fix that hole that was out in there. And we'll talk about some of this here as we look at the failover on what can happen and what can occur when we need to do that remediation of that, assuming a breach in there. So as I said, this is that endless cycle. These devices are constantly doing this, where they connect, they authenticate. Technically, if you follow the 802.11 standard all the way back, they actually authenticate first. It's just we do open authentication and wireless. We connect, then we do our ICE, our radius, or whatever, our pre-shared key authentication. We authorize that device, and then we re-authenticate periodically to redo our keys and everything. So you can see what can happen with this, Julio, is if we've got IoT devices. You go out to one of the customers and we're trying to troubleshoot this network with our tools, and they tell us, oh yeah, we just deployed 1,000 temperature sensors. They're all on wireless. Great, yeah, we're going to pull out our handheld device. We're going to start looking at the frame counts, and we're going to start seeing all the different frames that happen. I can almost guarantee you're going to see a ton of management and a ton of control frames because of this endless looping cycle that goes through for these devices to come on. And if the devices don't get the responses quick enough, what happens to them? They say, oh, they throw up their arms and say, oh man, this isn't working for me. They're going to give you an error. And it looks like it condensed down my slide here a little bit. Apologize for that on the screen here, but I'll read it anyway so you can see it. So what happens when the wireless or security backend fails, causing a failover event? A lot of times, that's going to trigger a re-authentication. So you think about it, you've got 1,000 devices that now have to re-authenticate. Instead of it being staggered connections that came online periodically throughout the day, throughout a shift, or whatever the case might be, you've got an instantaneous 1,000 devices that are trying to hit your Radius server or your authentication servers. The questions you need to ask is, will your server support that or won't it? And I've seen this happen. We did a live failover. We had a customer that asked us to say, we want to know what happens when 3,400 clients re-authenticate because of a failover. So right around lunchtime, we failed one of the servers. And we made it go over to failover. And it melted. It completely broke down. Windows wasn't able to handle it. Our ICE servers were good, but our Windows servers, the backend there, couldn't handle the request per second. So we ended up with quite a big issue and quite a big failure on that because we couldn't scale to support that. There are ways that we can test this, though, and we can look at this. So I mentioned, and we're going to look at this on the 14th, on how we can look at some of the logs of the .1x authentication process to see what happens with the authentication. But there's other ways that we can test it at scale as well. There's a Mac application that I really love called EepTest. And one of the things that I like about it, and this shows you how underpowered my Radius server is here in my lab, the fact that I had 2 accepts and 20 failures in just 28 seconds on there. Don't, it's not like I have this big compute platform here, so don't worry about it too much. But it shows the point that I can bombard my authentication server with a lot of requests. And I can see, are they actually going to process it or are they not going to process it? Because we need to understand what this full cycle looks like, because if it takes too long to happen, the client device is just not going to associate. We're not going to be able to get connectivity on there. We're going to have problems on it. Okay? So that's the authentication system. That's that authentication backend that we're talking about. Really important, something that always gets forgotten about. Again, because it's usually silo-based. You got security that runs that. We just leverage it. You got to come together and you got to work on it together to be able to ensure that this is going to work and be successful. All right. Whole time. Our last question. Talking about segmentation. Does creating different SSIDs segment the network? If I want to segment the network and I go through the process of creating my multiple SSIDs, now we all know hopefully that you shouldn't have too many SSIDs out there, but yes, we do have to have different SSIDs. But if I want to keep those IoT devices in a separate network, creating that SSID, does that segment the network itself? So let this run here for just a few here. Get some more results in there. I know, right? I'm kind of liking the odds here so far. Kind of liking where we're going. 3, 2, 1. All right, we've got 85% on no, 14% on yes. I don't know. Julio, does it segment the network? Well, what type of segmentation are we actually talking about when we're doing this? So from an RF standpoint, from a wireless perspective, having different SSIDs doesn't really segment your traffic, because wireless is broadcast. Everybody hears everything. There isn't like there's this predefined safety lane that says, okay, this is IoT, this is phones, this is guest, this is whatever. Everybody's on that same RF, that same non-physical medium, that unbounded medium. So a lot of times when we look at segmentation, it comes down to a physical switch segmentation of your access points, and then network segmentation from a wired perspective of your devices, because the SSIDs are always on the same medium. So when we look at physical segmentation, and how does this impact with Wi-Fi 6 and 6E, and why are we talking about it? Now, I don't mean that you're doing a single SSID per AP with each switch port configured. I have seen that. I have seen people do that. And like, well, hey, this is how I have to have this slightly air gap network. It's got to be completely different. But I'm like, it's not completely different though. Like, I'm not having anything that's separate on this. What it comes down to more so is PoE and failover support. So one of the things that you need to be careful, we kind of hinted at this earlier. Wi-Fi 6 and 6E APs, because now we have a third radio in there that's doing that 6 gigahertz support, which is that key element of 6E, they require higher PoE. Now, if you require higher PoE, that means that your switches potentially handle fewer APs. So if you've got your switches deployed today, and you've got, let's say, on a floor, you've got 16 APs on there, and they're all off of one switch, and you're migrating from, let's even go real far back. Let's go back to an 802.11n access point. You skipped a couple generations there, and now you're finally getting with the times. Or maybe you just finally were able to get your products in hand because you actually got them ordered. So now when we go to our Wi-Fi 6E APs and we plug those in, that same situation, if you did a one-for-one deployment, which I'm not blindly saying that's always what you do, you have to do the design properly. But if you did a one-for-one deployment, there's a high probability that your switch PoE budget will not be high enough to support all of those new APs. So those new APs are going to come online, and depending on your vendor, they're either going to come up in a degraded state or they're just not going to come up at all. You might not even have anywhere near the PoE budget on. So we have to do appropriate PoE budget calculations in order to ensure that those APs can be powered off of it. It's not about the switch bandwidth, because most all of our switches that have been deployed in the last 6-7 years have got plenty of backplane bandwidth and plenty of uplink bandwidth. It's always about that PoE and what also happens on a physical switch failure. I'm a huge fan of separating your APs out to multiple different switches just to be able to ensure that you have flexibility in case a switch fails, you don't lose your entire floor. I'd rather lose half my floor and have folks maybe switch over to GASP, that 2.4 gigahertz network that has a little bit better range, while I get my switches figured out, than having it completely fail over on them. So physical segmentation is more about PoE and how do we appropriately deploy our switches to ensure that our budgets are met. And again, we'll talk about on the 14th, we'll look at how do you actually test PoE, not just the availability of PoE, but do I have enough budget on that PoE? So following those ETNA, the Zero Trust Network principles from earlier, we verify then trust with limited access through our network segmentation. We still want to leverage those VLANs to segment via layer 2, but we also want to make sure that we extend that into layer 3 routed segments, and maybe even go as far as looking at SD-WAN technologies on how do we look at it and say, okay, you're trying to get to TikTok? Well, I'm just going to send you out an internet pipe. But if you're going to try to get to corporate, like HR file share or whatnot, I'm going to first send you up through this other route that goes through a higher protected, goes through different firewalls, different access credentials. I might actually look to see what it is that you're doing with that document, see if you should be leveraging that document, or if you're downloading it or viewing it, whatever the case might be. We want to further our deployments into that SD-WAN so that we can have a more granular approach to our devices. And one of the things that that's going to do for us that's really huge is that it enables us to be able to look at some of our IP services in a different way. And I like to look at this as more like a network tree concept, where treat your network like a tree with a bunch of branches, and each branch provides different support. So typically in the past, we did everything based off IP based. We said, all right, you're coming from VLAN 10, you're on 172.16.10.0, that means you get the access to this. But what happens if somebody just blindly gets onto that network because they plugged into the jack in Julio's office and it wasn't protected and they're onto it? We want to switch more now into that application base, that SD-WAN coupled with the ZTNA, so that we can dynamically allocate and say, okay, yeah, it doesn't matter that you're on this IP space. You're on this IP space, yes, but what is it that you're actually trying to do with that network? How do we change how we're going to direct our traffic based off of, again, that who, what, where, all of those different elements on there. Couple all that together to be able to say, all right, this is an IoT device. It's on STIX-E. It's on this SSID that our laptops connect to, but you know what? It's secure because it's using the same security credential levels. We just want to restrict who it has access to. We want to say your door locks, yeah, they only talk to your cloud provider that manages that door locks. You know, things like that. It's all about how do we get deeper down into this and more granular on a packet-based deployment. That's all about that software-defined network and that SD-WAN technology to be able to make sure that we allocate things accordingly. And one of the things that this will do for you, as we talked about this here a little bit, is it starts to make you readjust how you do your IP networks in there and how we work through our deployment scenarios. So in the past, we would have it where we got this wired clients network. I'm just using /24 as an example here. So this wired client was on a /24. We don't give them a restriction of access on it because you know what? It assumes that, hey, if I'm standing behind Julio there in his office and I plug into the jack, Julio probably invited me in there. And if you didn't, well, hey, we're friends now because I'm plugged into your jack. All right. It's a false sense of security, though, on that. We have to be careful about that because we can't just blind trust that. You go into lobbies and you plug into networks and they're open. Well, then we have the wireless clients and they're like, restrict all the things. Like, you can't do anything. It's so insecure because it's wireless. It's an unbounded medium. I've heard it all. It goes everywhere. So we become really restrictive on it. Well, now you've got that network, that /24 network, where people in the past, only a few folks were using it. And that's changed now. Where all of a sudden we're starting to see, okay, we've got more clients that are coming onto this. How does it impact us? And one thing that I always see is interesting is people always put APs on their own network. I'm like, why are APs so different? Why should they be on their own network? Is it a security risk? They create a tunnel to their controllers, or they create a tunnel to wherever their data plane goes off on. They're no different than a client device or a laptop device. It all comes down to your back-end services and how you have those routed, how you have them built onto it. So as we deploy Wi-Fi 6 and 6E, one of the things that comes up constantly is this all wireless office concept. And I'm running a couple slides behind here. I wanted to give you guys time for questions, so we're almost there. So we're doing okay on time. So this Wi-Fi 6, 6E all wireless office, we're getting rid of that mess of cables. It's really easy. You just start unplugging and you pull switches. But when you look at how you deployed your network previously, is that wireless client IP network ready? Was that network that you had defined as a /24, is that actually going to be able to scale and support now all these devices up there? Because the clients react completely different. There's a different authentication. There's a different association, DHCP workflow. It's all about latency and requests per second now. We have to be extremely cognizant about this and be able to react quickly and be able to offer up DHCP as fast as we possibly can, which is another area that we see a lot of issues with client devices as we start to do these larger 6E deployments, especially with IoT devices. A lot of times with IoT devices, their stack is really poor. It's a poorly coded stack or a poorly integrated stack. So how do we work with it? So something about DHCP that I see often is this whole debate about your release times. A lot of times when we looked at networking and wired side, we made our releases like a week. We made them 7 days because we looked at it and said, that device does not leave that desk. It's plugged in, it doesn't grow legs, and it doesn't walk. It just sits there. So if it just sits there, why should I constantly have it asking and doing that process of doing a DHCP request and DHCP response and going through that? That's unnecessary overhead. Well, the difference on wireless is that this device comes and goes. It's on the Wi-Fi, it's off the Wi-Fi. It's on the Wi-Fi, it's off the Wi-Fi. Every time you turn the screen on and off, it goes through that process, believe it or not. So what we want to do now is we want to have really short lease times. We want to be able to have it so that we can support those devices that are coming on and coming off quick. And why we do this is that it reduces the exhaustion. We're optimizing that allocation so that we can temporarily, keyword, temporarily scale easier, so that we can try to support surges in connectivity as quickly as we possibly can. Now, obviously, if that surge becomes normal, that means you need to readjust your plan and build accordingly. But if it's just temporary because all of a sudden you have 400 devices that you weren't expecting that showed up, you can support that. Reduces your scope sizes, reduces your actual network size, because if you only had that /16 because you needed to support that 7 days of lease time, that's a lot of waste. It's a very large broadcast domain. Okay, so it's all about, again, optimizing allocation, reducing exhaustion on there. Now, obviously, there's a little bit of overhead on there, but it's minute. It's pretty small on the grand scale of things. I don't see a lot of issues, especially when we have large stadium clients. I don't see a huge issue of this, because stadium, for example, we're going to put that lease time to be, say, for example, 3.5 or 4 hours, because it's enough for an event, but then it's replenished again right away for the next event that's coming out into it. You're going to see more requests per second, so that is an overhead concern. I have to make sure that my device can support that. And then obviously a failover risk. We do have a higher risk of clients not coming back after failure events because they may have an address, they don't know that the server switched, there's some issues on with that. But it is, the pros, trust me, outweigh the cons on this short lease time, and it lets you scale and support 6E a lot better. The last item, name services. DNS requests per second matter as well. And the reason why this matters is, we hit on this once already, captive portal network authentication. All devices these days do that, where they look to see if there's, I shouldn't say all, IoT devices usually don't. All user-based devices do this. If they can't resolve a name because, for example, you're using internal DNS servers, or you're using DNS servers that are heavily utilized and have a huge delay in them, say, for example, your ISPs, don't ever use your ISPs DNS servers, always use something else. That could inadvertently trigger the captive portal detection saying that there must be a captive portal, or it's going to flip you in and says there's limited connectivity or no internet connectivity. when the reality of it is you actually do. And sometimes getting your device to go out of that state requires you to turn off your Wi-Fi or turn your device off and turn it back on and go through this entire process again. So that request per second is huge. It's extremely important to make sure that you have it so that you can scale and support that and be able to handle those client devices. Ultimately, all it comes down to is that, is there hope for your Wi-Fi 6, 6E network on the backend side of things? I hope there is. I hope that you can look through some of these different concepts in here and some of these different thought processes of how you need to change your thoughts from previous so that you don't end up becoming meme fodder where now all of a sudden, yeah, that's right, passwords. He's got all your passwords. The hacker already has all your passwords. Or we're not getting DHCP addresses. I see that constantly when I go out to customer sites when I'm doing performance tests and validation analysis. You've got to be able to scale all those IP services. Make sure that that's going to be able to support an influx of devices, whether it's temporary or permanent. You have to be able to support that. Those quick responses. Everybody says it's not the DNS, but a lot of times it is DNS. DNS is the lifeblood of the network, of the internet for so many, because if we didn't have DNS, you couldn't just hit netally.com. I'd have to say, hey, Julio, what's your IP address? And I bet you Julio would look at me and say, I have no clue. I didn't deploy that server. And that's the truth. So we need to be able to ensure that you can actually get those resolutions, get that information out there and be able to have to do that. All right. So we got 4 minutes to the top of the hour. Apologies. I meant to leave a little bit more time than that, but let's see if we have if there's any questions, please feel free to put them into that Q&A chat right now. While we're waiting for any questions to pop up, Julio, you want to add anything in there?
Yes, so far, no questions. Thank you, Blake. That was a great session there. So one question I have, I guess, one thing we didn't talk about, and maybe it's because of time here today, what about more like a gateway type of problems? You mentioned DNS, DHCP. What about the gateways?
Yeah, gateways is a whole nother can of worms when you look at that. And I like to say is that for most people, traditionally speaking, in their networks right now, it kind of mirrors that statement of switches have plenty of backplane these days.
Mm-hmm.
For a lot of it, the gateways have enough backplane as well. They have enough of, we really haven't overran too much of our bandwidth into those, unless you're talking like you're somebody like, a large scale data center, AWS style facility, yeah, then you've got some big concerns about it. But for the average users and the average businesses out there, your gateway infrastructure should be able to support everything. I see it more as the next top, that firewall that's slowing it down, because we're asking our firewalls to do so much more now.
Yeah.
That's really where it becomes key to look at what is the bandwidth per sec that you can be able to do once you enable all the features. Like that's the key. Is you can't just look at the marketing numbers. You then also have to look at it says, oh, the fine print that says, if you enable all the security features, here's how much throughput you can actually expect.
Yeah. Yeah, good point. Good point there. And remember, guys, if you have any questions, feel free to type those into the questions chat. I'm here watching those. So if I've been quiet, it's because I'm paying attention. So, and there is one question here. Hey, there we go. So let's see. For the 2.4 gigahertz and 5 gigahertz, when using multiple SSIDs, there will be one beacon for each SSID. How about in the 6 gigahertz band?
Yes. So we actually did a blog post on that. By we, I mean the royal we of me, wrote that blog post, and it is, you can see that on the NetAlly Wi-Fi 6, 6E webinar links that we have out there. But that's kind of one of those interesting questions, is that if you read a recently posted document from Apple on supporting Wi-Fi 6 and 6E, mainly the 6 gigahertz, their recommendation is to have all 3 bands have the exact same SSID. And there is a very valid point to that in terms of, especially when we're looking at home devices and home users. Yes, it makes the most sense to do that because it enables them to be able to roam freely between 6 gigahertz, 5 gigahertz, and 2.4 gigahertz as they go throughout their house without any issues. Now, there's other things that we can leverage, such as reduced neighbor reports, to be able to find 6 gigahertz networks, 5 gigahertz networks, vice versa, when you're on the different frequency bands, to be able to help clients roam. So in an enterprise environment, one of the key elements and key aspects of that blog post that I put together was, and honestly, it comes down for me is it's going to come down to is the security side of things. I'm kind of leveraging this as a way to be able to migrate to WPA3 because 6E on 6 gigahertz requires you to use WPA3.
Yeah.
Not all your client devices are going to support WPA3. And we've all seen what, if you've been in this environment or been in technology wireless for a while, you've seen what's happened when we've done transitional periods from WPA to WPA2, where we have both enabled. Some client devices don't like that. So for me personally, I'm leveraging this and I'm looking at this as in the enterprise space, I'm going to turn up a new SSID for 6 gigahertz. I'm going to put that as the same base name as what my SSID name is. And then I'm just going to add, hyphen something or add fast after it or faster. I don't know, whatever you want to do it these days. But I'm going to leverage WPA3 on that. And I'm going to use that as a way of being able to do support somewhat of a slow migration of being able to also make sure that my client devices can support WPA3. I don't want to rip that Band-Aid off quite yet and say everybody's got to go to WPA3. I think there's a lot of client devices, a lot of IoT devices that stack is just not stable enough for me. I mean, I even see issues in my house personally on my iPad, my brand new iPad that I just got that supports 6 gigahertz and WPA3. I see some issues with it trying to connect to that network. So I don't want to go to that quite yet. So I'm a huge fan of doing the multiple SSIDs for now. Remember, it's not adding additional overhead because it's on a different frequency band. That's the key, is we can have an SSID for each of the frequency bands, and that's perfectly fine because it's not all on the same band. So it's not adding additional overhead. They're separate entities, so we can get away with treating them like that. But yes, I would definitely, Kim posted in, Kim's the silent social media marketing person in the background. She posted in the chat there. We'll see if we can answer that onto that question. Or she posted in the, somewhere like that. We can put it in, can I put that in there?
Yeah, let's see here.
I was going to put it as a reply to the answer of the question, but I can't. In any case, it is on this next slide right here.
There you go.
So yes, find that blog post here, netally.com/Wi-Fi 6-6E-series. You'll see it on there. It's pretty good. We discuss and look at that same question in more depth about the whole adding an additional SSID, if it's okay, if it's going to add overhead. There's been a few folks as well. Ben Toner, Numerous Networks, he wrote iOS application for doing log analysis. He's been doing some discussions, and he's got blog posts on Twitter as well that they've been talking about that whole issue of the additional SSID. So definitely go look out. There's some additional resources out there that you can do there. If you want further information and you can't find it, there's my email address, as well as how we can get a hold of Julio and the team as well. So feel free to email us and we can put that information together and get it into your hands.
Indeed. And well, Blake, it seems like we're a little over time and there's no more questions for now. Thank you again very much for hosting today's session. That was a great one. And for you guys watching us at home, remember that this was recorded. So if you want to watch it again, hey, feel free to. Also, Blake has here the schedule for the next sessions. So Blake, I'll let you cover that pretty quickly.
Yep. So head on to that same link. It's got all the webinar overviews there. You can register for those upcoming webinars if you haven't already registered for them. If you have, thank you. We appreciate it and glad to see the early support on it. But that's where you can find the next ones. And remember, on the 14th, you're going to be able to win a G3 potentially.
Woo-hoo.
All right. Thanks a lot, everybody. Appreciate it. Have a great rest of your day, rest of your evening, whatever might be going on.
Yep. Thank you, everyone.